So we have discussed measure of variability, measure of center tendency. We also discussed z-score and mean center data in last class, and we said now we will move to very important thing called distribution. Now before we go to distribution, let's come to a simple game, and you might have, this is the agenda today and we will talk about it later. Okay. You might have seen a game like this in the toys market where there is a triangle and then first dot, second dot, 3 dots. So we have 1 dot, 2 dot, 3 dot, 4 dot, 5 dots. In this way, the number of dot in every line is increasing. Okay, and then your target is to get the ball from top at the particular box, which is nothing but in between 2 dots. Okay, so if we have here 5 dots, we have actually 7 because one can go here and one can go here also. Okay. So this is nothing, this was invention of Mr. Francis Galton, who was very famous statistician, mathematician. Okay, and today we will be building on his work to understand basics of distribution. Okay. So this is a simple game. Now let's go mathematically. So let's talk about what's a distribution and let's talk about a Bernoulli distribution. So whenever we are trying to do something, either it can be a failure or it can be a success. In simplicity, though there can be multiple things, but in simple things it can be either a success or a failure. That's the simplest Bernoulli trial. I am not saying every event will lead to only 2 outcomes. In a simple case, any event will lead to 2 outcomes, either the output is favorable, non-favorable, yes, no, as you want to define. Okay, the simplest one. We will discuss probability also. So any single event has a success rate full of P. That means the probability of event being successful is P. What is probability? Likelihood of event happening among all the possible events. Okay. Now each single event can be successful by a probability of P. So which means if I am going to score more than 90 marks, 90% marks, for me the event is successful if I score more than 90%, and it is possible that the probability of event is 0.5 for me or 0.4 for me, which means if I give 10 times the paper, 4 times I get 90%, more than that. For more talented people, it could be 0.8, 0.9, 10 times they will give and 9 times they will get 90%. So that is a simple definition of success. Success being a probabilistic event or probability event. Okay. A single event has a successful rate of P. So as I told you, it is a very simple thing. There are 2 outcomes. That's a Bernoulli event. Please understand. We are not saying all distribution like this, but this is a simple thing. Okay. So possibility of being successful is P, or probability or possibility, though they are 2 different words, but for our case, let's have it as similarity. The probability of getting 0 is 1 minus P, because there are only 2 events, and as we know, sum of all possible events, when their probabilities are combined, it becomes 1. So there are only 2 outcomes here, failure and success. The failure has a probability of P 1 minus P and success has a probability of P. So P plus 1 minus P becomes 1. Okay. Now when we have such a data, okay, and we give success the value 1 and failure the value 0, then the probability of the result, the mean of that data will be P. Variance will be P into 1 minus P and notation will be Bernoulli of P. Okay. This is a simple mathematics. So please understand. So as we told, a successful event has got value 1, it has a probability P, unsuccessful event has value 0, the probability is 1 minus P. Okay. Now When you do it single time, the probability of success is P. Now, what happens when we do it n times? That is we have to see. When we do only one time, the probability of getting 1 is P, that we know. What happens when we do it n times? And that is what will happen. That means, okay, let's say I am tossing a coin, the probability of heads is not half. It's not a biased coin, it's a biased coin, it's not an unbiased coin, is 0.4. So P is 4. What is P? Probability of getting a head on this coin is 0.4. So if I have only one toss, I can say the average value is 0.4, which means if I give success as one value, the average value of this trial is 0.4, which means 0.4 I will get. Now, what happens when we multiply it n times? I do it 10 times or n times, the probability becomes NP. Sorry, not the probability, the mean. The mean becomes NP. Okay? We will come to that, but you have to understand this. An event has only two outcomes. One outcome has a probability P, which we call as success. One outcome has the probability 1 minus P, which we call as failure. Okay? That is about telling what happens when we do multiple trials or trials n times. So, this is the probability NCX, okay, Px 1 minus Px. So, I will come to I will explain you this. What is NCX? NCX is a combination of okay. So, NCX is n factorial divided by n minus x factorial and x factorial. This is NCX or NCR. So, I will just take you to a little bit of combination thing. What is a combination? So, if there are n things, how many different combination of R things at once is possible. Okay. Now, let us talk it again. Let a practical example. If there are 4 teams A, B, C and D, 4 teams A, B and C and D, and there is a match, and match needs only 2 teams. So, the question is how many matches I will have, okay. Or if I am taking 2 teams at a time, how many such possible combinations are possible, which means in a match either A is playing first or B is playing first, does not matter. If A and B are together, that is one match. So, if you see practically, if you do not know combinations or permutation combination, no problem. What we will do, A will play 3 matches, one with B, one with C, one with D. So, first match is AB, second match is CA and third match is DA. A has played all matches. Now, B will play with C and B will play with D, and again last C will play with D. So, in total we have 6 matches, which is 4C2. 4C2 is equal to 4 factorial divided by 4 minus 2 factorial divided by 2 factorial. Okay, which makes it 4 factorial. I assume everybody knows what is n factorial. N factorial is n into n minus 1 into, this is multiplication, n minus 2 till 1. So 4 into 3 into 2 into 1, 2 into 1 dot 2 into 1, this becomes 6. So instead of drawing that combination, I will say 4C2. Let's take this example first further. We had 10 teams in the World Cup of 2019, I suppose, and I don't know about 2023 World Cup. Maybe it was there. You might be knowing it better. So if there are 10 teams in a World Cup, how many matches we will have? Just at the league stage. I'm not talking of qualifying or quarterfinals or finals or whatever it is. Just the league stage. Every team has to play another team. Now there are multiple ways, but I will just say 10C2. 10 into 9 into 8 factorial divided by 2 factorial divided by 8 factorial, which becomes 45. So we will have 45 matches. This is what a combination is. Okay. So in the Bernoulli trial, NCX is out of n trials, how many success I am looking? I am looking for x success. That will be P into x 1 minus P n minus x. And this is what we will use in calculating from now on, understanding a binomial distribution or normal distribution. All sort of distributions are starting from this. This becomes very important. I will repeat it again. Okay. Let's go back to slides and I will come back again to this. Okay. The probability is this, where C and x is a combination number of x. So total number of success of a variable x, out of n times, how many times I will get x. Okay. This again we have told the notion. Please understand the notion here, because there was no n, there was only one trial, so BP. But when you have multiple times the trials are happening, the notion is big B, small n and small p. P being the probability of the success, n being the number of trials. Okay. Now look at this. This, as we have written, Galton box, Pascal triangle, Bean machine, all these are synonymous. Now what is the Pascal triangle? I will just tell you. One thing, you have 1 here, then you add 1 and 1, then this becomes sum of 1 and 2. Okay. So every subsequent layer is got from the layer above. 1 is in the outside, layer is outside boundary is always 1, inside 1 plus 2 becomes 3, 2 plus 1 becomes 3, 1 is 3, okay, then 1 plus 3 becomes 4, 3 plus 3 becomes 6, 3 plus 1 becomes 4, 4 plus 1 becomes 5, 4 plus 6 becomes 10. So you are getting from top to bottom the values. Now we will talk about this, what exactly is this. Okay. Now let's go back to game right now. Suppose this was, you had a game in which there were n number of balls. Okay. Now the n number of balls were from the top of the Pascal triangle or the Galton board was dropped. Okay. And at the bottom the balls were collected. The balls would be collected in this way. Okay. Let me make it simple again. And we come to our whiteboard. Okay. If this is the Galton board, there are only 3 possibilities. Okay. A ball will go to left, and then after that it will go to left again. So if you have 2 L, you will end up here. When you come here, for here either you can have LR or RL. This is possible. Either you go first here and then take right, and first go right and then take left, and here you will take RR. So this becomes 1, 2, 1. Okay. Now let's look at again at higher level, 3 levels. Okay. Now you will come here when you have L, L, L. Okay. You come here when you have R, R, R 3 times. You have to take R here, then R here, and then R here. Only then you will land up in this bin. Here you have to take left here, and then left here, and then left here 3 times. Here you will come if you take L, L, R or L, R, L or R, L, L. Here you will come if you have L, R, 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 L, R, 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 L, which means there are 3 ways to come to this particular point. Now let us check it again, how there are 3 ways. So if you take a left, let me draw it again. So let me change the color here. Okay. So you come, you take a left, okay. You take a right, sorry. You take a right, then you again take a right, and then you take a left. So this is R, R, L. Okay. Let's try another one. You take a left, then you take a right, and then you again take a right. So this is called L, R, R. Okay. And last one. If you take a right, then take a left, and then take a right. Okay. So now if you see what are the values coming here, 1, 3, 3, 1. So 1, 3, 3, 1. Okay. So in this way, when I go for an extended triangle where 1, 2, okay, let me draw it bigger circles. Now here again the most leftmost ball will be L, L, L. This will be R, R, R. L, 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 R, L, L, R, R, L, R, 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 R. Okay. Now what the interesting thing is, how do we get these values? Either you can multiply, add them, but as we have done in Pascal triangle, so 1, 3, 3, 1, 4, 6, 4. So this will be 6 values here, 4 values here, 4 values here, 1 value here, 1 value here. Okay. Now how is this related to our equation of combination? What is this? This is if there are 4 places, place 1, place 2, place 3, place 4, and I have to select only 2. Select any 2. Why 2? Because we are selecting 2R or 2L here. Okay? Then that becomes 4C2. 4C2 is nothing but 6. So Pascal triangle or combination, they all are linked. Okay. So in this way you can see this is the values which we were writing. Okay. This is 1 by 2 means this is 1 by 16 by 1 if you have 32 trials. Okay. In this way the triangles will be made. So we wait 1 3 3 1 1 4 6 6 1 1 5 10 10 5 1. Now what is the denominator? Denominator is 1 plus 5 plus 10 plus 10 plus 5 plus 1. Okay. This is 32. Okay. Similarly 1 plus 4 plus 6 plus 4 plus 1. This is 16. So if you see the what we say the denominator is actually power of 2, 2 to power 1, 2 to power 2, 2 to power 3, 2 to power 4, 2 to power 5. Okay. In this way as you go ahead, each row is a Bernoulli trial where at every point you are deciding either you are going left or right, or you can say success or failure. Okay. Now in this case, because we were assuming symmetrical data, okay, that probability of right and left being equal, P is equal to 1 minus P, which is equal to P is equal to, which means P is equal to 1 by 2. Hence this value will come, and we will show you how next. This is what it means. The probability of success R success from N is NCR P2R 1 minus P N2 NSR, which we have written in the terms of X. Okay. So this is a binomial distribution. It has a mean of NP, variance of NP into 1 minus P. It is only symmetrical when P is equal to 0.5. We will get to the line N is large, it becomes to a normal distribution. For that I need to explain you what's a normal distribution. Okay. But binomial distribution is about an event which has only two possibilities, and if there are n trials, each trial has a success of probability P. Then if I am looking for R success, the probability of R success is R being a whole number, not half number, okay, not decimal or not fraction. NCR P into R, okay, P to power R 1 minus P whole power n minus R, or sometimes we say 1 minus P is equal to Q. So NCR PR Q n minus R. I will rewrite NCR PR Q n minus R, where P plus Q is equal to 1. P is the probability of success or one event, and Q is the probability of both event, second event, both being added becomes 1. This is a binomial distribution. It has two. Okay. Now what does the distribution mean? Let me show you the photographs. What does this mean? As you can see, the middle values will get most of the balls, and as you expand it, irrespective of number of what we say slots, number of trials you have, there will be a image like a histogram of will be like this. Okay. So in first case it was 3 3 1, in next case it will be 6 3 no 6 4 1. Okay. So in this way this becomes a distribution. It's a histogram. If you see number of successes 6 4 1. So in this way, as you increase your n, the histogram will keep on changing. Okay. So this is what we were saying. Left means fail, right means success. You can define anyway. So if there are 5, there are 0 to 5, there are 6 outcomes. Okay. So how do you say? We have discussed this. So 5C2 is 10, 5C3 is also 10. So getting 2 balls here means 10, getting 3 balls here is again getting balls in the second slot being numbered like this is 10, getting slot in the third numbered like this is also 10. Okay. So in this way the balls will fill. As you increase your n, the shape will be following this distribution itself. NCX, PX, Q, n minus x, x and n both are whole numbers, and p plus q is equal to 1. Okay. Now we will talk about it in further class, that how this translates to binomial, or sorry, normal graph. Thank you very much.